So you've come to the point in your hypothesis testing for scientific inquiry, your correlational analysis, where you need to calculate the R statistic, also referred to as Pearson's R, or Pearson's correlation. Now, as with all of the other calculations that we've done, it's very important that you lay out the numbers that you need for your calculation before you start. We have the numbers that you're going to need up here that you've already determined. They're in the table in your book. And here I've copied out the formula, and you should do this for yourself on your own work pages so you're very, very clear which numbers you need to plug in here. And we're going to talk through this so there's no doubt in your mind about which numbers go with each of these, which numbers are indicated by each one of these symbol sets. All right, so let's just talk through this. Starting with the numerator, you see that here we have n, which is your sample size, that's 10, and you're going to take the sample size n times the sum of the xy. And the sum of the xy is right here, 3578, right? So this value comes from multiplying the subject's attention score times the subject's radar detection sensitivity score, right? And if you multiply each subject's x times each subject's y, and you add those together, you get the sum of the xy's. And you're going to then subtract from that the sum of the x's times the sum of the y. Very easy, all right? Now the denominator is a little bit more complicated. It's going to be the square root of the solution to this. And so in the first part of this equation, we have the sample size n times the sum of the x's squared, you have that value here, minus the sum of the x value squared, as indicated by the parenthesis, times, and then that number is going to be taken times the sample size 10 times the sum of the y squares, which is here, minus the sum of the y values squared, as indicated by the parentheses. So the only values that you need to complete this calculation that you don't already have up here is the sum of the x squared and the sum of the y squared. Now before you calculate this through, I recommend to keep yourself organized that you calculate whatever value you don't already have before you start on the equation. It'll make your life a little bit easier. Okay, so let's just do this right now. We're going to square 123 and we get 15,129, and then we're going to take the sum of the y squared equals, and the sum of the y's was 223, and we're going to square that, and you get 49,729. Great. Now you have all of the values that you need. That's a 9. To calculate this formula, right? So let's just draw a line here. Let's start our numbers, and I'll go to another board if we need to. Let's start with the numerator. It's 10 times sum of the xy, which is 3578, right, minus sum of the x, 123, times sum of the y. Oops, 223. Right? Okay, so let's get the numerator first. So the numerator for this problem, this is obviously 3578. 0 minus 123 times 223 equals 27,429. And if we take 35780 minus 27429, we get 8,351. Okay, so you already have the numerator for the problem, right? That was easy. 8,351. And let's just do this. And now let's work on the denominator. Okay, so we have the sample size n. First of all, be very careful not to forget that square root sign. It's very important. So it's n which is 10, times the sum of the x's squared, 23410, and we know that that is 23410. Minus the sum of the x's squared, and that's 15,129. And then we're going to take this times the same thing we're going to do with the y-scores, right? So this is n, 10, times the sum of the y-squares, which is this. So we know that that's 59230 minus the sum of the y's squared, which is 49,729. Oh, that's starting to look a lot easier, right? And of course, we're working only on the denominator now. So let's just do this. We have 23,410 minus 15,129 equals 8281. We're going to take that times 59230 minus 49729 equals 9501. Now, of course, when you multiply these numbers, you're going to get a very large number. Don't be afraid of that. All right, so now we're going to need the square root of 77781, and you hit the square root sign, and that becomes 8870.05 if we round. Okay, 8870.05. And that's a number that's certainly within the range of our numerator, right? So now if we look back at our numerator and we add in our denominator that we've just calculated, 8870.05, and let's carry that through. 8351 divided by 8870.05, you find you have an R value of positive 0.94. We'll round it to. All right? All of these numbers are given in your book. I hope you're able to follow that calculation. Now you're at the point of determining the significance of this result.